Okay, and so this is the book that we're going to use. Elementary and Intermediate Algebra by Marvin, David, and Barbara. Last names in their respective order: Bittinger, Ellen Bogan, Johnson. And this book is published by Pearson Education in 2002. So this book came out the year I entered the 7th grade. Okay, so let's get started. And first of all, I want to thank the people who made this book possible, the authors, the publishers, the reviewers, and everyone else. Okay, here we go. So chapter 1 is titled Introduction to Algebraic Expressions. And I'm going to go ahead and read to you each section that we're going to go over. 1.1, Introduction to Algebra. 1.2, the cumulative, associative, and distributive laws. 1.3, fraction notation. 1.4, positive and negative real numbers. 1.5, addition of real numbers. 1.6, subtraction of real numbers. 1.7, multiplication and division of real numbers. Again, 1.7, multiplication and division of real numbers. 1.8, exponential notation and order of operations. Again, 1.8, exponential notation and order of operations. It is followed by connecting the concepts, then a summary and review, followed by a test. Okay, so let's read this side box here by Sharon Crowell, who is a development engineer, or was a development engineer, but possibly still is a development engineer, based in Richland, Washington. She said, "The math we use every day is mostly algebra and geometry. We determine the constraints like weights and dimensions, and then design robotic equipment that works within those constraints. Using the math correctly makes all the difference in whether the equipment does its job or not." So, as you can see, math is very important. Okay, here we go. Now, 1.1. So I'm not going to read all of the text. I'm just going to go through the main points, and then as well, I'm going to focus on the highlighted words, the vocabulary words, because we all need to know every single math term if we're going to learn this course. Again, this is algebra. This is intermediate and elementary algebra. I'm using their book, Pearson Education. So here we go. All right. So now I'm going to try to keep the text focused here on this phone's camera and the phone's camera lens while I'm also trying to read it. Okay, so 1.1 is about algebraic expressions, translating to algebraic expressions, and translating to equations. So, okay, starting at the top, I am actually going to start reading here. Problem solving, let's do this. Problem solving is the focus of this text. Chapter 1 presents some preliminaries that are needed for problem solving approach that is developed in Chapter 2 and used throughout the rest of the book. The preliminaries include a review of arithmetic, a discussion of real numbers and their properties, and an examination of how real numbers are added, subtracted, multiplied, divided, and raised to powers. So many of these topics are taught in grade school, all the way down to elementary, but usually starting in middle school and continuing on into high school. So here we go. Let's see, the first highlighted word here, the first vocabulary word that I see in this algebra book is variable. This term is very important. Now, just for myself explaining, without thinking about the text definition, a variable is a letter that is used to represent a number for something else, a value for something else. So we can have the letter A or X or B. It could be any letter that is used to represent something else. Now here's what the book says about that. Underneath algebraic expressions, it says, probably the greatest difference between arithmetic and algebra is the use of variables in algebra. Okay, let's read that again because I got distracted. Probably the greatest difference between arithmetic and algebra is the use of variables in algebra. When a letter can represent a variety of different numbers, that letter is a variable. So for example here, we have, I need to stop that from beeping, but I don't have any way to pause. I don't have any way to pause, so I'm just going to continue on. Okay, so for instance, they're using the letter N right here to, let's see, okay, using the letter N to represent the number of tickets sold. So in this example illustration here, this scenario is trying to find out what is it going to cost to, or what is the total amount of money going to be made here, but they say total collected, which is the same thing as the amount of money made for this venue hosting this event. So the variable here is N. Okay, for example, if N represents the number of tickets sold for a Los Lobos concert, then N will vary. That means it will change depending on the day. On one day, it's going to be maybe 159 tickets sold. On another day, maybe 17 tickets sold. So that's what it means when it says they will vary. The N will vary. And again, the N represents a number. Okay? So this N is representing the number of tickets that will be sold or is sold in the end. Okay, so let's continue reading. For example, if N okay, here it goes. N will vary depending on factors like price, the day of the week. Thus the number N is a variable. So there we go. Enough reading from that. Then we have a constant. Constant is something that doesn't change. It's just like the English word constant, meaning it stays the same. So here it says the number 25 is called a constant because it does not change. Let's go back. What is 25? If every ticket costs $25, okay, so that's the constant, 25. If every ticket, that means it's not going to change. It doesn't matter what day of the week, it doesn't matter what time it is, the ticket price has been determined that it is $25. If every ticket costs $25, then a total of 25, and you see that little dot in the middle? That dot means times, okay? That's a multiplication. So 25 times N dollars, the number of N dollars will be paid for tickets. N represents the number of tickets, okay. So note that 25 times N means 25 N. The number 25 is called a constant because it does not change. Now, the reason why I'm going over this so many times is so that way you understand. This is what it is meant by a variable, and this is what it is meant by a constant. Okay, now the expression 25 times N, or as we often say it in algebra, yeah, is 25n. So the expression 25n is a variable expression because its value varies with the choice of n. So an expression, variable expression, it contains a variable, which is a letter standing for something else. An expression, because it varies with the choice of n. It says the choice of n because remember, the n can change. At one point, it may be 25 tickets sold. Another point, it may be 14 tickets sold. Okay, let's go down here. Evaluating the expression. Okay, so now if we're going to find out how much money is going to be made, then we need to evaluate the expression. We use the information that we have to come up with the answer. The cost per ticket is $25. That's the constant, it does not change. The number of tickets sold, they change. At one event, there were 400 tickets sold. At another event, there were 500 tickets sold. And then at the last event, there were 600 tickets sold. So we use this variable expression, 25n, to determine the total amount of money that is sold. This is evaluating the expression here. We're multiplying using the information that we have from the variable expression, 25n. So 25n, 25 times 400 is $10,000. So on the first event, they made $10,000. On the second event, 25n, or 25 times n, 25n equals 12,500. That's how much money they made that day. And finally, 25,600. 25 times 600 equals 15,000. So there we go. That is evaluating the expression. That's talking about variables, constants, variable expressions, and evaluating the expressions using a real life scenario. Okay, now we're moving on to the next page. Okay, what else do we see here? Algebraic expression. It says variable expressions are examples. Variable expressions are examples of algebraic expressions. So these things down here, variable expressions. Variable expressions are examples of algebraic expressions. An algebraic expression consists of variables, which again are letters, and or numbers, often with operation signs, and grouping symbols. Examples are t plus 97. That t is a variable. This plus sign is an operation sign. And then this 97 is a number. I think I said number earlier, but that says numeral, which is this. This is the same, as far as I know, as a number. It's just a different word. Maybe there's a slight difference, but overall they're the same. Okay, then we have 5x. Again, this dot is, usually the dot is only used for beginning courses of algebra. This is like the very beginning, the baby stages of introducing people from the world of arithmetic, where you're just adding, subtracting numbers, and that's pretty much it. Dividing, basic early level grade school math. The dot in between two terms is how we introduce our new learners to understanding that we're multiplying. For the majority of this book, there will not be a dot. It'll just be 3t, 4x. It won't be 4.x, 3.t. So this is only temporary that we see this dot. Maybe for the next few pages, and then it's probably going to disappear forever. Okay. All right, here we go. So we have 5x, and we have 3a minus b, 18 divided by y, 9 over 7, or 9 divided by 7, and 4r times the quantity of s plus t, or as I personally like to say, hold on, let me get this focus back. Okay, this is how I like to say it. I like to say 4r open parenthesis, or open parenthesis, 4r open parenthesis, s plus t close parenthesis. Okay, let me wipe off this camera lens, because that might be the reason why it's blurring out. I don't know if that's it, but it's a possibility. Okay, let's just try to refocus. Okay, so here we go. We just learned algebraic expression. Okay, now when we back down here to the problem, when we evaluated this expression, we substituted the number in for the number of tickets. So we substituted the number into the variable for n. Okay, so this is what this is talking about right here, substitute. We already did that. To evaluate an algebraic expression, we substitute a number for the variable in the expression. This replaces each variable with a number. Okay, here's example 1. I'm just going to go through these because we need to see these. Everyone has to start somewhere. So I'm going to assume that this is all new to you, or you are willing to learn this very early level stages of algebra, if you're willing to review it or learn it. Okay, example 1, part A. Well, it says at the top, evaluate each expression for the given values. And part A, or letter A, is x plus y for x equals 37 and y equals 28. All it's saying is substitute the number 37 for where you see x in this algebraic expression, x plus y. So let's do that first. Oh wait, I'm sorry, no, this is to be done together. Okay, so we substitute the 37 for the x. So that's going to be 37 plus y. Now it says, and y equals 28. So we're going to substitute 28 for the y here. So it becomes 37. So x plus, let's start over. X plus y then becomes 37 plus 28. Okay. Oh, there it is right here. We substitute 37 for x, 28 for y, and that expression equals 65. Okay. So 37 plus 28 equals 65. We will see this again very soon when learning a property. Okay. Again, 37 plus 28 is equivalent to 65. I'm saying that for a reason, but I'm going to hold off for now. And B, same thing with B. Substitute 5AB for A equals 2 and B equals 3. So that's exactly what's done here. We substitute 2 for A and 3 for B and multiply. So 5 times A times B becomes 5 times 2 times 3. 5 times 2 is 10. 10 times 3 is 30. There we go. Now, example 2. This is talking about finding the area of a rectangle. I'm not going to get deep into this because we're going to learn more about this formula. But just read what it says and proceed. It says the area of a rectangle, length L, that's the length, and width W, that's the width. Again, the area I skipped that A. The area that capital A of a rectangle of length L and width W is given by the formula. Area equals length times width, or A equals LW. Find the area when L is 17 inches and W is 10 inches. Solution. Okay, wait. Let me just go ahead and explain. So we're trying to find the total area in this triangle here. Okay? So what we will do is use the formula for area, which it gives us. Okay? It says find the area by the formula A equals WL. So we don't have to guess anything. It's telling us what the formula is. We just have to substitute the values. Okay. I turned off my AC because, AC can make noise in the background. So I'm fanning myself. I'm gonna cut this video short because I need to get something to drink. But because let's see how many more pages there are in 1.1. Yeah, there's a little bit more. I'm gonna stop here, cool off, and come back. We will pick back up on example 2 with the area of a triangle, or area of a rectangle. Thank you for watching the beginning series of Introduction to Algebra.